Okay, my name is Didi Harrington, and I'll be presenting on guinea worm disease. So, guinea worm disease is officially known by the name dracunculitis. It's a parasite, the infectious agent is Dracungulus medenicis. It's a roundworm parasite, so it's related to other roundworms, meaning they have long, cylinder-like bodies. Um, and basically they rely on hosts to survive. Um, the parasite is contained within vectors, specifically copepods, so water fleas. Um, the larva of the parasitic worm, will be swallowed up by the flea, and the flea will act as a vector. The main route of transmission is through the consumption of contaminated water. So the water flea will be in water, and then a human host or an animal host will consume it, and that's how the transmission route occurs. It can also come through eating infected food, specifically fish. So if you have a fish that's eaten water fleas with the larva in it, the fish will be infected, and the human or the animal that eats the infected fish will get the parasite, become infected. So the disease has a long history, maybe not as well documented as others, but there are ancient mentions of it. So Rufus of Ephesus in the 1st century AD, he linked the disease to contaminated water. So they didn't necessarily know what it was, but they knew that drinking this water would cause this guinea worm, essentially. There's also mentions in the Bible of a fiery snake or fiery serpent, which many think is in reference to guinea worm disease. It wasn't classified until Carl Linnaeus did it. Specifically and scientifically, he classified the parasite. And then from the 1800s till 1900s, there was a lot of research and discovery into the role of water fleas, how it worked as a parasite, modes of transmission, all those things. And then in 1986, a global eradication effort was launched, specifically by the Carter Center. And then here you can see as an image that's actually a Catholic saint, Saint Roche, I believe is how you say his name, or Roch, R-O-C-H. But he's a Catholic saint depicted with the disease, specifically the telltale sign, which is the worm coming out of the leg. So the life cycle of the guinea worm begins as a larva, and it's basically consumed or taken within the vector. Traditionally, water fleas is the main route. Then when the water flea is consumed, either through water or an infected fish by the host, the flea will basically protect the larva until it reaches the stomach, in which the stomach acid will kill the flea, and the larva will be basically let out into the stomach. And once in the stomach, it will go into the intestinal tissues. So basically, the flea protects it until it can be released within the human host. Sometimes the larva will be killed, but traditionally it makes its way into the stomach tissue very well. And then once within the stomach, it will make its way through the body, traditionally in the upper half, so within the spinal cord, within parts of the stomach cavities, within connective tissue. It will basically live there and grow and feed off of the nutritive power of the host. So male worms typically last about 2 to 4 months is their lifespan. They typically mate with a female larva in the body as they develop, and then will die. And basically just get consumed or taken up within the host body. The female hosts, however, will either reproduce or grow on their own. So typically they'll reproduce with the male, and then they'll find their way into some part of the body, like I said, like the spinal cord or cavities in the stomach. And they will grow for 10 to 14 months, basically just growing and living and feeding off of the host. And at that point, once they've reached full maturity, they'll start to make their way down the human body to the lower extremities, specifically the legs and specifically the foot. So they'll make their way down to the lower parts of the bodies. And once they're ready to release their eggs, they'll make their way to the surface of the skin, and a blister will form on the top of the host's skin, and the worm will emerge from the host. The reason they do this is because they want to release their eggs into a water source so that vectors, specifically water fleas, can pick up the larva and continue the life cycle. So pick up sorry, they'll make their way to the top of the skin, and when the host place their leg in water or something of that sort, they'll emerge from the skin, releasing the larva. Typically, they grow to about 2 to 3 feet in length, and they need to be either manually removed or they'll emerge on their own, but it takes like weeks for them to emerge on their own. So typically, they're pulled out manually by the host. They can die within the body, though, and if they die within the body or while being pulled out of the body, they can rot and cause abscesses or infected wounds, which can cause a lot of secondary issues for the host. And basically, the larva, once released into the water, will continue the cycle. So the main symptoms, like I said, are the blister. However, there's also possibility of fever, swelling, and nausea. However, the problem with this disease is that people don't know they have it until the symptoms emerge, which is until the worm comes out of the leg and the blister forms. So that's 10 to 14 months after infection. And like I said, there's high chances of bacterial infections, specifically the blister becoming infected, the blister from which the worm emerged. There's currently no vaccine or no treatment specifically available for guinea worm disease. It is basically just manual removal. There's some medicine for like pain release and antibiotics to stop infection, but really the main treatment is just removing the worm. So the most at-risk populations are those without access to clean water sources. So that primarily includes like sub-Sahara areas and parts of Asia. So that's either lack of access to clean water, lack of awareness of the disease, lack of reporting of where infected water sources are, which leads to infection within mostly, like I said, rural areas. There are ways to diagnose the disease actually through DNA samples in the body where they can be given to a lab and grown so that we can see if a host contains the parasitic DNA. But typically the people who are getting the disease don't have access to these resources. So they wouldn't know they had the disease, even if, I mean, only if they had access to these laboratories, but they don't. And like I said, it's mainly found in sub-Saharan African land, specifically Chad, South Sudan, and Ethiopia. And then, sorry, this image here is a picture of a dog with the disease. So you can see the worm emerging from the animal, and dogs have actually caused a problem in recent eradication efforts, which I'll get into later. So eradication efforts were started by the Carter Center in 1986, and basically their main route of eradication was just providing clean water. So in 1986, there were 3 million cases of the disease. In 2025, there were 10 reported cases. The primary way of reducing this and eradicating this disease is simply through providing people with clean water. You can see in this image these straws. That's one way they've provided filters for people to drink water. And these filters aren't crazy or anything. They're just to keep the water fleas out. However, like I said, there's been some limiting to eradication, which is the infection of animals. So animals infecting water sources that humans wouldn't, because humans are aware that they have the disease. Limited healthcare access, and then also like instability in regions, mistrust of organizations like the CDC and the WHO and the Carter Center. But overall, global eradication is estimated to be by 2030. And these are my works cited, and yes, thank you. you enjoyed